Okay, so what I get after a couple of false starts, I have the wrong power 10 here. Okay? First of all, let's just look at this R over L term, or R over 2L term. A Henry is a volt second per amp, right? And an ohm is a volt per amp. Okay? So if I look at that, well, I've got a per amp, I've got a volt per amp here and a volt per amp here. That's just going to leave me a second in the denominator, right? So I've got reciprocal seconds. It looks like a -2. It wasn't, but it looks like it. So, well, isn't that exactly what we expect to get? Because we've got an e to the lambda t, it's got to be e to a pure number. So lambda t had better be a pure number. Well, t's in time. This is in reciprocal time. Lambda t is going to be a pure number. Has to be. And this is a pure number as we checked out with the units down here. Okay? The number here is pretty easy. Well, the number over here is real easy. Okay? We got a 10 to the negative third here, which is going to give us a 10 to the third up here times our 10 is going to give us a 10 to the fourth. We're dividing that by 2. That's 5,000. Okay? If we know that 10 to the fourth is 10,000, we can divide that by 2 and get 5,000. Okay? Over here, let's see if I did it right. Okay, we're squaring 10, right? Now we know these units are going to work out to a pure number. As I say, we already checked it out. So we've got 100 here times 10 to the negative fifth is a 10 to the negative third. You divide that into 10 to the negative third and you get 1. So we got 1 minus 4, which is negative 3. So now we've got 1 plus or minus the square root of 3 times I. Okay?
Sure, why don't you do
I don't do,
Now,
I'm not good at thousands and stuff in my head.
our solution, so Q is what? It's A e to the negative 5,000 per second t multiplied by 1 plus or minus the square root of 3i. Okay? That's our complex number. Well, that's going to be, and it's not, it's e to that power, okay? E to the 1 plus or minus square root of 3i. So it's e well, it's that times e to the plus or minus square root of 3i. So Q is going to be A e to the negative 5,000 reciprocal seconds times t times what? It's that times I2, right? And I is not a vector. You should do it. I've been working with quaternions. Okay, so anyhow.
Is that
we got,
1 plus or minus?
Huh?
Is that 1 plus or
No,
minus?
we got the 1 from this.
Oh, yeah.
Okay?
Right, yeah.
So what's this? Well, that's just an e to the I theta, right? Where theta is square root of 3t. So that's times cosine square root of 3t plus or minus I sine square root of 3t. Well, that leads us to Q equals Q naught E okay? Multiplied by, in change the parentheses there. Okay? We're going to take the Q naught off of here. I'm going to say, okay. Or B is an arbitrary constant. Make sense? And that shouldn't have been a Q naught there because we can see will behave at 0. Meaning, it doesn't take much of a T to make this thing approach 0, right? It's going to rapidly approach 0. And the only way you're going to get around that is to have no resistance. Okay? If you have no resistance, you end up with this equation, okay, which gives you just a pure cosine function, okay? And you don't have the exponential decline. Now, how could we make the exponential decline slower? Well, we can reduce the resistance. Of course, as the resistance that approaches 0, this approaches e to the 0, which is 1, right? Okay, just again leaving us this. But the other thing we can do is we can decrease the inductance. Now that's going to have an effect over here too, an effect on the square root of 3 here. If we decrease the inductance, this number gets bigger, which gives us, turns out, a bigger number in front of t, which means we're going to have a higher frequency. Okay? And then we want to think about this in terms of just what's going on in the inductor, the capacitor, and the resistor, and how that affects the nature of the solution. So this is kind of a solution to the LRC that kind of gives us a handle on something. Okay? Then we ask ourselves things like I just said, what happens if we eliminate the resistance? What happens if we increase or decrease the inductance, increase or decrease the capacitance? And what's that do to our circuit? And then what happens if we're driving it with some variable source voltage? Okay?